So, hello dear friends, once again welcome in this channel. Now let's talk about how to find out the inverse kinematics, how to analyze the inverse kinematics. Inverse kinematics analysis. Before that, we know the forward kinematics versus inverse kinematics. So, in forward kinematics, this is the forward kinematics, forward kinematic, and it is the inverse kinematic. Okay. So in forward kinematics for the given joint angles, what are the Cartesian coordinates? It is input and it is output. But in the case of inverse kinematics, now for the given Cartesian coordinates, what will be the joint angles? Now here, x O output becomes input here, and the theta is output here. Okay. And what is the beauty of inverse kinematics then? Inverse kinematics is more practical, more practical, and it provides what? Either single solution like forward kinematics, multiple solutions, multiple solutions, unlike forward kinematics, and no solution unlike forward kinematics. So single solutions कब होता है? In the case of when it occurs, if there will be singularity. Singularity means losing one of the degrees of freedom, means degrees of freedom. And multiple solutions means to reach, what is this? To reach the same goal points. There will be multiple ways. Okay. And no solution means, what is the meaning of this? The target points means the x, y are suppose, no, not x, y, the target points are beyond the reach of the manipulator. Beyond the reach of the manipulator. सिंपली वो आउट ऑफ रीच है, वहाँ तक हमारा एंड इफेक्टर मैनिपुलेटर पहुँच नहीं सकता. सपोज हम वॉल पे वेल्डिंग करने जा रहे हैं और रोबोट वहाँ तक पहुँच ही नहीं सकता, तो दैट इज द केस वेयर देयर विल बी नो सॉल्यूशन एग्जिस्ट. ओके. नाउ, so what is the beauty of this inverse kinematics? The giving multiple solutions. Okay. Okay, now let's talk about analysis. So we know for this, suppose this is the robot base and this is the link 1, link 2, because it is a rigid link. Okay, L1, L2, and it is the end effector, and it is a theta 1 and it is the theta 2. So through the geometric approach of the forward kinematic analysis, what we get? X is equal to L1 and cos theta. So we are writing here C1, L2, C12, and C1 is what? Cos theta 1, C12 is what? Cos theta 1 plus theta 2. Okay, similarly Y, L1 sin theta 1, L2 sin theta 1 theta 2 means sin S1 S2. Okay. Now to get theta 1 and theta 2, so we are squaring x and adding with y square. Then what we get? It is L1 C1 plus L2 C12 square L1 S1 plus L2 S12 squaring it. Okay, and simplifying it. Squaring and simplifying it by putting C1 2 is equal to C1 C2 minus S1 S2. Similarly, S12 is equal to C1 S2 plus S1 C2. What we get this? We get this in this form: x square plus y square, it is equal to L1 square plus L2 square plus 2L1 L2 C1 C2, and from here we get C2 is equal to x square plus y square minus L1 square minus L2 square, then divided by 2L1 and L2. Similarly, we can get S2 with plus minus sign, it is 1 minus C2 square. So what we get ultimately, we get this we're not talking, this we can get, our focus is here, plus and minus. What is this? So there will be two, as we know there are two possibilities, like two possibilities to reach the goal point. This is the goal point, means xy unaffected, and this is the base of the robot. So this one configuration is known as elbow down posture, and this is the elbow up posture. Okay, तो आप देख सकते हैं to reach the XY means suppose these are the goal points. तो एक तरीका तो ये है कि elbow down posture and other which elbow up posture. So इसका मतलब we are getting two solutions in the case of two links manipulator. Okay, now we can get the angle, hence the angle theta 2 is calculated as theta 2 is equal to a tan 2. It is S2 comma C2. Okay, where a tan 2 in contrast to simply a tan is a function in any computer language like MATLAB, C, Fortran, etc., which computes the value of tan inverse in appropriate, appropriate, appropriate quadrant. Okay, in this way the theta 1 can also be calculated. A 10 2 and it is S1 comma C1. So in this way we can derive the inverse kinematics for suppose 2 links manipulator, 3 links manipulators, or even the various complicated manipulators like Puma, Kuka. So in this way we have done. Thank you.